Today's August 31st is today. Yeah. All right. Welcome to ChabDev, everybody. Welcome. First, have to thank these lovely sponsors who make the food that you have in your mouth and bellies right now possible. So thanks to all you lovely folks out there who help support this wonderful community endeavor. Next week, we've got Camillo coming to talk to us about Git internals. So that'll be a fun talk. Camillo's great. If you've not seen him before, this will be his second or third outing at ChabDev. Second in not too long a time, but we're pleased to have him back. Anybody have any community announcements they'd like to make before we kick this thing off? Negatory. All right. So we've got Will Wade here coming at us from CarbonFive. Yeah, shout out. Got the family love in here today. So everybody give him a round of applause. It's all yours, Will.
Hey, everybody. How's it going? Check, check. 1, 2, 3, and we're on. All righty. So today we're going to talk about metaprogramming. And like a little bit with enlightenment, those who know do not speak, and those who speak obviously do not know. But we're going to do our best today to learn a little bit and get through. So why would we want to talk about metaprogramming? For a lot of common reasons. For most programming, we want to hide complexity. We want to work on eliminating redundancy. That's a very common thing we'll see in some of it. And metaprogramming also helps you think differently. So once you start thinking about the code as opposed to what the code is actually doing, but how you actually work with the code itself, I think it can definitely help move you towards a way where you're thinking in general different about code, a little bit towards enlightenment there. And of course, what we always want to be, because we're here eating lunch instead of doing it, we want to be faster at development. And we're going to work through that. There are lots of different types of metaprogramming. There are generators, there's classic template metaprogramming from C days, there's macros, there's transpilers, there's compilers, there's even a whole bunch of research metaprogramming that is crazy, and I will be excited to come to your talk on it. But let's get into generators. So generators are probably the most common thing and the most common type of metaprogramming that you've interacted with. Hopefully you've done some stuff with it. And you kind of have a few different types. We've got specific to a framework. We have a specific language tool that does the generation for us. Or we have something that's more generic. We'll look at Plop.js real quick. That allows it to work language agnostic. And there's a bunch of others. So when you're working with generators, maybe you're working in Rails. Here is a simple generator for a helper in Rails. And believe it or not, all you need to extend this generator, to build out this helper, is to add this file here. It's not a whole lot of code. It's literally just the template for the file. We have the module name. We have maybe an attribute reader. And you're just having code that's taking, it has its own syntax, perhaps, for the templating. That's unique in this case. It's standard ERB code. And you take that and you're writing code instead of writing out your HTML. Really simple to use. A lot of frameworks have them. Here is the Yii generator for the Yii PHP framework. And again, it's using PHP templating. So there's nothing special that if you already know PHP, if you're writing in PHP, then you both know how to write the code because you're writing in PHP. And you know how to write the template syntax because you're already using it for HTML. And so I'm suggesting that you go out, you find out whatever your generator is for the framework that you're using, and you figure out, well, where are these things coming from? Most of the time, it's merely copy it, paste it to your own file, and modify it to your heart's content. And I'm hoping very much that if nothing else, that you all will go out and look into, well, when I generate that helper, where is it? I always have to do this when I generate a controller. I always want to add this line or import this thing. And I want to encourage you very much to go out and start your journey to enlightenment of metaprogramming by just simply modifying the templates that you're probably already using. You may not necessarily know you are, but now you do, so you don't have an excuse anymore. If you perhaps want to get a little more crazy and try generating things that aren't always in the same language, the Plop.js is a simple little generator tool. You build yourself some JavaScript here to, in this case, we're generating a controller. It has some questions that it can ask you. And then it's going to spit out a template, maybe a template that looks something like this. Plop.js uses kind of a modified version of Mustache. And so you've got a little bit of logic in here, not quite as much necessarily as available to you as if you're using an ERB or a PHP template syntax. But you've got a lot, and it's language agnostic. So you can go and you can turn around and build little generators for a whole bunch of different things and kind of keep them all in one place. That's another option for you. Another entirely separate option that, again, you've probably used is a bootstrap generator. So this is going to actually generate an entire application. There's a lot of them. Brand new one out here. Razor works with Elixir and Phoenix and works great. But there's also agnostic ones like Yeoman. And again, a lot of frameworks also have their own built in. So you may not necessarily need to go to something terribly generic. But you've got some nice benefits of going with the specific ones. So like Razor, for example. Razor is opinionated. It's very simple to use. It's a collection of best practices, and it's built in Elixir. So if you're already writing Elixir, which if you're generating an application Elixir, hopefully you're getting into Elixir at least, and you can turn around then and use that knowledge to modify, extend, contribute to any of those kind of pieces and parts. And it's nice, one little command, Razor new name of app. And then you've got your app. If you want something more generic, you've got something like Yeoman. Yeoman, 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 Yeoman. So here we have lots of different generators. It's language agnostic. There's over 6,000 generators that they list. But their quality isn't always, yeah. It's got a nice little, there's 1% that's good. And 1% of 6,000 is still a lot. But finding the 1% can sometimes be a little hard. But in this case, it can do CRUD generation as well. But on the other hand, since it's language agnostic, each kind of package has its own set of dependencies that you have to manage and worry about and make sure are installed. It doesn't really do a lot of that dependency management for you. And it uses NPM, which may or may not be a good thing for you. So here's a little example of how to use it. NPM install, it's a global install of Yo, and then you globally install a generator, and then Yo and the name of the generator, and you can call help, and it's got some flags to generate, do you want React in this application, and those sorts of things. So it works pretty well and does what you want. And the templates, here's a JavaScript template. It's, again, pretty simple. It's kind of got an ERB-ish syntax. And so here we're generating some JavaScript. We've got some then, hey, if we're going to include Bootstrap, we're going to put it in here, but we're going to comment it out. This is kind of a simple way to easily add some templates. Again, the nice thing about it is you don't have to be very complex. You can start with some very simple things. Are there files that you're generating that have different pieces and parts that are that you modify, or you want some if statements about? It's an easy way to kind of get started with them, and you can easily build your own templates and generators. Hopefully, out of the 6,000, there's one you don't have to modify too much. And so generators give us this nice ability to take a lot of code, write about the code, write logic about what pieces and parts we want, and to output it very easily. We get a nice application at the end. We get a nice controller. We get a nice controller that always also has a test that goes with it. You know, we generate a controller perhaps, and we tell it a couple method names. And the test then also says, hey, make sure you implement that method, these method names as well. It gives us some ability to easily do things, and specifically not to forget things. The easiest thing to do when you're copying and pasting from an old controller or something like that is to forget to delete some code that's specific to that controller, or conversely, not to add, oh yeah, I've got to import this other thing that I always import except in the one I copied from. And it's a lot harder to remember to import something new than to delete old code, so we just kind of keep deleting old code and copying over. A generator gives you a chance to both be explicit about things, explicit about what's included, and give you the chance to be very verbose about, you know, put in a comment about why this is here, and stuff like that, stuff that you wouldn't normally do just on a copy and paste from an old controller. You can kind of make sure you're thinking about the controller as I'm going to build a quality controller, as opposed to I'm just going to build another controller because I've built 50 of them already and I'll copy and paste and here's another one. So there we go. So if you want to start in metaprogramming, I suggest using a generator. And yeah, now you can actually leave if you want. But if you stay, I promise you more enlightenment as we get into macros. So macros are primarily used in compiled languages. And although it is possible to have a Babel transpiler that has a macro type setup, it's going to be a bit interesting. And you think, because obviously I'm up here talking about macros, you think right now that maybe I need a macro. I think I need a macro. Or you've come across the situation where you've learned enough about macros and you think, this is it. I need a macro. You know what the answer is? Nope, you don't. You don't need a macro. And so you think, maybe I do. I'm going to go and ask a friend. Because my friend, he knows a lot about macros. Maybe she can tell me whether this is a good idea about macros. And what's your friend going to say? Don't write that macro. Just don't. But wait, maybe you're one of those people who doesn't have any friends. OK, you know what? You can go ahead. Try writing a macro. You're fine. All right, you've written a beautiful macro, right? Now guess what? Don't use that macro. And so let's learn some more about macros and find out maybe why this is. So macros are great and powerful things. And like most great and powerful things, you need to be careful with them. So for one thing, macros operate at a level that is in between when you write your code and when your code is compiled. It happens during the compilation process. And we'll kind of talk a little bit about where in a little bit. And before it's actually at runtime. So you're actually dealing with code, not runtime. So one time when you would definitely want to use a macro is when you have to do something at compile time. Most common thing that I've seen that you really want to do something at compile time is something like adding the git hash into your code. So when you compile, you want to add the git hash into your code. Well, when the code's running, it doesn't know anything about Git. It doesn't know anything about its code. You have no access to that. So if you want to do something at compile time, you've got to use a macro. Good luck. Second, if you want to extend the language. So you can do some wonderful things with DSLs, and we'll actually take a look at some in a minute. But there's a downside to extending the language. So think for a second. If you have someone from, let's say, Michigan, who comes down and talks to someone from here in Tennessee, they are speaking the same language. But that does not mean they can communicate very well. And when you extend the language, you have that same problem. You have lots of people who know Elixir. That's great. You've below changed Elixir by adding in a whole bunch of macros. You've now changed the language so much that someone's like, I mean, this looks familiar, but I have no idea what it is. And so that's a problem. It's both an advantage and disadvantage. And so it's one thing that you have to be careful with. You also might want to use a macro when you're really writing the same thing over and over and over again with a couple modifications. And this is where macros often get used in Phoenix, the Elixir web server setup and controller framework. It handles a lot of your routing through macros so that you don't have to go and write a whole bunch of pattern matches that it can write for you. Very nice. And it lets you take that and hide all that complexity of writing those pattern matches and put it into a nice, simple interface that works really well. But if you're writing your own macro that's not a framework-level macro, hiding complexity has its downsides. Because sometimes you want to be explicit about what you're doing, and sometimes you want to hide that complexity. And frameworks give you a chance to hide that complexity. APIs and other libraries give a chance to hide complexity. And so the question is kind of, is that complexity that's important to your application, or is it complexity that you want to hide? And again, that's kind of where we got to start wondering, do I really want to write a macro? And then the #1 reason to write a macro is for fun. It's fun. You should do it. It really does help you think differently, and we'll get through some here in a minute. Macros, when they're happening at compile time, so you have your code that's going to be compiled, and the compiler runs through. This is fuzzy and generic, so take it for what it's worth. You're going to run through and you're going to build up an abstract syntax tree of your application. And so that's going to look like a tree structure. It's going to say, it's going to let the compiler know better, this is actually an if statement, and the if statement has these branches. And so when you're working with a macro, you have access to the abstract syntax tree, and you can even modify that abstract syntax tree. And you get to access the abstract syntax tree through something called quoting. So quoting is what's telling the compiler, instead of on that first pass through the abstract syntax tree where we start evaluating things and building up our actual program, we want to stop and we don't want to evaluate it yet. We want to wait until later. And then we have to take it and the compiler needs to undo that later on. And sometimes we also need parts inside of it, because sometimes you want things at one level and sometimes at another level. So once we start dealing in macros, we're kind of dealing with two levels. We have the level of code that we're working at the macro level, and we have the level of code that's going to happen at runtime. And quoting and unquoting is what's allowing you to shift between those two structures. So here's a little example. You can quote if, and then our test, that's going to come in at runtime. So we want to unquote that. We're going to make sure we don't actually evaluate that if statement yet. In Elixir and Clojure, the two languages we'll do examples in today, Elixir has a nice little quote and unquote. Clojure has a few little syntax pieces, including the single quote and the syntax quote, which we'll show in a minute what it actually does separately. And so here is actually some abstract syntax tree. Isn't it great? We've got, so we're going to quote, so we can get out that abstract syntax tree. We're going to quote a block that is just 1 plus 2. And so once we get that out, we see that we have our actual function call here, which is an addition. We have our context, and we have our list of imports, so we know what we're dealing with and what's possible. And we have our list of arguments. It's quite simple. And so we're going to quote a case statement, right? And this one looks a little bit crazier, but again, we have our function call to case, and we have our environment, which in this case is nothing. It doesn't need any. We have our x variable that it's going to pass through. We have our do blocks with our two function calls here and here to match on anything in Elixir. And we have our true statement there. And we have, way down at the end, we've got our actual text. Everything that you see here is indeed in this. In Clojure, Clojure is fun. Clojure is a Lisp language. And so when you quote something in Clojure, it comes out looking generally a whole lot like what you just typed in. Because Clojure, based on Lisp, effectively you are writing, for the most part, in an abstract syntax tree. You aren't actually compiling something that looks nice and pretty with case and do blocks. You're actually going from the actual abstract syntax tree, which, if you've heard a lot of Lisp and Lisp macros, macros are popular in Lisp because since you're used to writing an abstract syntax tree already, it makes it very easy to back up and write something that modifies what you're already writing. If you're trying to modify an abstract syntax tree in Elixir, it can be a little daunting because you have to learn an entire new syntax. It still works, and you don't have to generally read all this out that often, I should say. But it's definitely helpful to be able to work in the syntax that you're used to. Now, we're not quite done with quoting yet. There's one other piece that we'll talk about, and that's the unquote splice. This one's actually fairly simple. If you're used to using a splat or a spread operator from ES6, then basically it takes it in, if you have an array or a list or a vector, it takes that and instead of inputting that array or list or vector, so that's these extra parentheses here, and applying it to the function, it's going to spread it out and remove that array structure and basically drop it right in there as a list of as arguments, as a list of arguments as opposed to a single argument. And we'll see that in a couple of examples as well. Now, we still aren't done. This is kind of where we're getting a little slow here, figuring things out. Time to wash our hands of this thing and get to hygienic macros. So once upon a time, macros were very generic. This is not real code over here. But basically, they took something and they literally just replaced whatever was there. A couple symbols changed maybe. So maybe you've got a macro that sets A to 0 and adds one to the X value. But if you then have an A value set outside of it and you have a B set to 2, macro B, that just sits in there and replaces A0 increment B, and we end up with A being 0, but we never actually saw that happen. It's hidden back there in the macro. And so people came up with various fixes. They use convention. You always need to, if you create a new variable inside of your macro, make sure you always name it something unique. Well, guess what? People are terrible at coming up with unique things. People are terrible at being random. So they came up with a better idea, which was, we're going to generate symbols for you. So if you tag your variable in a certain way, in this case with the hash, that's how Clojure does it. Kotlin also uses gensims to generate new values. Then you've got a new value. It's generated, and you aren't modifying that scope outside of it. And then finally, in things like Elixir, they have automatic hygienic macros that gives you the ability to, when you, in the end, it does the same sort of thing that a gensim does, generating that symbol, but it allows you to never have to worry about if I have a new value, it's always going, if I have a new variable, it's always going to be that variable and not a variable from outside the scope. So, now we're ready to take our abstract syntax tree and actually write some actual macros. Alrighty, here we go. This is a famous macro. If you've looked at all into macros, you've probably seen this one. This is the unless macro. So you have an if statement. If true, then do something. The unless is if false, do something. It just inverts the if statement. A lot of languages have this built in now. And here's the function version of the unless. It just has a clause, a test clause. It has that expression, and it's going to say, if not clause, then do expression. Now, the macro, on the other hand, is going to quote. So we're moving, quote, we're moving to the macro time. Quote, not, we're going to unquote the clause because we want to get the clause from outside of the macro time. Clause, then do, again, unquote the expression. And then here is the unless in closure. These are actually two different ways to do it. So closure, you call an if function. The first argument is the test. Second argument is the true value. Third argument is the false value. And so you can quote if and then say not, and then this is our unquote symbol for closure. Test. So we're, again, exactly the same thing, nothing different. And then we're going to use that spread operator to push our two branches. Little syntax here. The ampersand gives us the rest of the arguments as an array. So we're going to just take that vector and throw it across and splat it right there. Now, and this indeed uses the same sort of syntax. Now, another option is we could actually say, unless test and branches, we could actually leave this test. We don't have to not test. We could actually just reverse our two branches, flip them over, just flip the order of the true and false. It works almost the same way. And you might be wondering already, how on earth do we know what these things are actually doing? Well, welcome to expanding your world and macros. So here's that Elixir unless macro. And so we're going to quote, we're going to call our macro, our unless macro, with true and then a little string out. And then we're going to run this whole long list of things, which will give us a nice string representation of what the code actually evaluates to. And here it is. So if not true, do something. Nice and simple. Nothing terribly special. Let's look at the closure one. So here we're using the macro expand command. We're going to quote our unless, true, false. And then we have, here's our expanded version of not. So it's namespace. That's what this little syntax quote gives us, is the expanded version, the namespace version. And then test. So if not test, false, true. It works. Now what about that other one where we reversed them? So here it is. Remember we decided to not do test and to instead reverse the branches. So true and false are flipped. And we can indeed expand that out, and we get if test, true, false. Looks exactly the same. You know, it doesn't have the not in there, but it's the same result, right? Well, the problem is, and this is one of the kind of the biggest issues with macros in general, is that you aren't quite as safe as you are just writing code. And so the if statement can, instead of taking two things, it can often take one. And so you can just say, if something true, do it. And so if we give it, instead of giving it two things, we quote it with just one thing in there. So unless test, do something, then suddenly we have if test false, which means that if this is true, we're going to do this, which is the exact opposite of what we wanted. But that's because when we reversed, instead of reversing a list of two things like we did up here, we reversed only one thing. And a reversal of a list of one thing is still that one thing. So expanding macros is a nice way to see those. But it's a great example of how when you're writing a macro, you can get yourself into a situation very quickly where you aren't exactly sure that what you're doing is actually what you're doing. And that can lead to, instead of easy compile time errors, because this is correct, there's nothing wrong with this, they can lead to a nasty runtime error where, wait a second, why are those people getting their stuff for free? They shouldn't get that for free. So let's dig a little deeper into a real macro. That's a nice one to explain it. Let's get into some real ones. This is a real Elixir one. This one's from the arguments package that I've written. And so here's a macro. It's building up a domain-specific language. And we're going to build a macro of a command. And we don't really need to look that close at the actual macro. Let's look at the DSL. So this is where it's nice. We have this nice little, we have a module that we've defined. We're using our arguments that triggers off the inclusion of all our macros and whatnot. And we can just say command something, do stuff. Command flag, do stuff. Flag dir, do stuff. And so we're actually going to, our macros are going to take this new syntax that we've created and convert it into something different. And again, we can quote to take a look at, we can quote like our command, new, do, and we can quote that and expand it and see what is it actually doing. And this is a great one because here we can actually see that we have a name that's coming in, and it's actually getting defined. And this is, since Elixir has hygienic macros, we know that this isn't going to hurt anything from outside. And here's our actual block. So let's go back real quick and look. So we have a name and we have a block, right? So here's the macro. And we're taking, it takes in a name and a do block. And then we're going to quote, but we're going to bind some quoted things. Elixir has a nice way, instead of having to go in and throw in unquote, unquote, unquote all over the place, it can just say, well, I'm going to bind, and typically you bind the same thing to itself, but you don't have to. I'm going to bind name inside of this block to an unquoted name later on. And so this one's very simple. It just adds to an arguments. And it just runs this one function, really. That's all this really does, is it says builder.createArgMap, and it takes a name, which is the unquoted name. It takes a block, which is, again, the unquoted block, and it takes command. And there it is. So we've defined our name and our block, and here's that one command that we're basically, that one function we're calling. And we've got name and block, and we can see now that name is equal to new, and our block is equal to arguments, a vector of arguments. So that was the simple one. Now we're going to get on to the flag. Flag is a bit more complex. And so here's the flag macro. And here we're doing a few different things. We're calling some functions. We call out builder get defaults. And then we're actually going to quote something. This is exactly the same as the other one for the most part. And we're actually going to take that quoted value, though, and then turn around, put it into an argument that's outside of the quoted structure. And then we're going to throw it back into another quoted structure right here. And then we're going to unquote it. So the question is arguments currently quoted or unquoted? Good question. It's very difficult to understand as you're moving quickly between levels, between that level of whether I'm working at the macro level or whether I'm working inside of it. In this case, we're dealing with something that's been quoted, so it's still quoted outside of it. And then it's actually, once we put it inside of quote again, it's getting a secondary quote, then unquoted, so that it can run at the proper time. And we can see that in just a second when we look at the expansion. But you remember that long thing we had to write for expansions? This whole long list of things. And we had to do quote, do, and all this. Why are we writing that again? We're in macro land. Let's build ourselves a macro to do it. So again, I'm jumping levels here. And we have built a new macro here. It's called the expand macro. And the expand macro just takes a single block. And here you can see it does that exact same piece of code. It's going to take the block, quote the unquoted version of the block, and then pass it through to the macro expand, the macro toString, and it's going to stick it out for me so I can easily copy and paste it into my presentation. And so now we can do, instead of that whole expand stuff, we now can do my_macros.expand to call it and do, and then just put it in there. And what we end up with is, here is the expanded version of it. So we have our name and our block, just like with the last one. And we're passing that stuff into builder.createArgMap. And then we also have this function we're defining here. Let's back up a second and see where is that coming from. So here is that we're actually defining a function. This will be defined on the module. And we're actually going to unquote it with a name. We're going to pass a symbol to it. And that is actually going to end up being, if you're familiar with Elixir, it's actually going to be a pattern match. So we can define this function over and over and over again, and with different pattern matching. And then we're going to take unquote defaults. Defaults here can actually be, we know it's a function because we ask, is it an AST function? And so we actually have a function we're calling in here, and we're going to unquote that function, and then we're going to turn around and call it with the x from the internal default args, the second argument. So let's look at how that expands, because that expansion is, again, the way to understand what on earth is going on. And so here we're defining our function, internal default args. We've got that name there, which is coming actually from this string, from the name string up there. And it's going to take, it's going to build that function. So here's dropping in that function. Let's go back and look and see if we can see that function. Here it is. Defaults, function, their name, and then it's building up that for us. And there it is again. There's it takes an in and passes it into there. And then this is our way to call it in Elixir with the dot something. And so then we call it. Whew. Everyone feeling either tired or enlightened? I don't know, both, a little bit of both. All righty. All right, we did Elixir. Now we're going to go to Clojure real quick. So a little bit of Clojure syntax before we get there. This is an arrow macro, actually. And it allows you to take a list of data and then function calls and then nest them. So here you're taking, you would take the result of function 1. You'd apply data to function 1, turn around and apply that to function 2, and then turn around that and apply to function 3, so forth and so on. And we also have this nice little thing in Clojure, and a lot of other languages have this, that apply function, which allows you to apply an array of things to a function, right? But now let's smash these two together, because that's a smart idea. And this is what Swiss arrows did. And so here's a slightly modified version of their macro, which takes and applies things while chaining them. And so we're going to ignore most of this. The only thing we really want to look at here is you see that hash. So we're building up a function way over there with x hash. And that x is going to get gensimmed. And everywhere else that we see x hash, that's going to be that same that same symbol. Remember, in Clojure, we don't have that hygienic macro that we do in Elixir. So we're actually going to have to generate a symbol for that so we don't mess up. So, you know, most of the time when you're looking at something like this and you're like, maybe you're trying to work with this, you know, somebody else wrote this code, that's when you really want to you want to start expanding. And so, you know, we tried first. There we go. Apply, arrow. This is a bit contrived. It was late. And we're going to take the vector of 1, 2, 3, and we're going to end up applying it to plus. And so the fun thing here is we can do macro expand just 1. So you can have macros that call macros. So you need to be able to expand them possibly multiple times. Most of the time, you can actually, there's different calls. You expand once or expand all. And so we're just going to expand once. And so we're going to quote our little apply arrow function. And we're going to end up with the call to a macro plus this, and plus you see here how it's converted into an apply call for us. And then we can expand that again, and we end up with our final result, which is apply plus our vector of 1, 2, 3. Ooh, even crazier, I know. But here's the, because you're going to go home and you're going to think, man, I didn't understand half of that, but the guy was like, you should write a macro, even if you don't use it. So I'm going to go write a macro. Here's number one tip. If you're going to write a macro, and we saw this a bit before, do most of your actual macro, the work of the macro, you don't have to do it in the macro. You can just do it in a normal function. And so you can say, hey, here's my macro, and I'm going to quote my macro. Here's my quote. And then I'm going to call a function inside that, and I'm going to pass it my unquoted things. And then inside this function, I don't have to worry about any of that quoting stuff at all. It's all done. I can test this separately. I can do whatever I want here. I don't have to worry about it. Now, if you're messing around with the AST and having some crazy fun, then you can't do this quite as much. But as we saw way back here, you see most of the work of this DSL in Elixir is actually that create arg map. That's a separate function, separately tested, easy to work with. And so the actual stuff we're doing there is fairly limited. All righty. The end. Or is it? Before I ask for any questions, I want to thank you all for coming out. There are a lot of great resources on macros out there. I suggest if you work in a compiled language, go read up on your language's macros. You can find a lot about Elixir in their macro list, and Clojure also, Brave Clojure has a great talk about writing macros and trying to slowly understand what on earth is going on. But the number one way, of course, to learn how to write macros is to go out and actually write a macro. So go have fun. Any questions?
Got a few minutes for questions.
Yes, sorry. So Elixir and Clojure are specific languages that have macros available to them. And so that was the syntax for those. You have macros in Kotlin. Swift has macros, doesn't it? I'm not sure. And has Go gotten macros yet? Nope, not yet. They do. OK, so, and of course, if you're doing C, there's various levels of macros in the various versions of C. And you can, if you really want to, just play around with it, but you're not wanting to go learn a new language. A great way to start is to go find a Babel transpiler that is a macro Babel transpiler, and it will have a lot of the same sort of stuff to kind of get you used to some of the concepts inside of that. Any other questions? All righty, go and be enlightened. Thank you all.